All right, welcome back. In this video, we'll be compounding interest, but we'll do it continuously. And so really what this means is that there's a change in the sense that we have a different formula. And the formula is the following. Some of you know it as PERT, but basically it's a model again. And we have A, which still stands for the amount of investment after 2 years. Excuse me. P is the amount of the initial investment. R is still the interest rate, and T is the time. Now we don't have to worry about N. And we do introduce this E. And this E, if you remember, I've explained this before, but in case you forgot, E is a number. And the number is that E is almost or approximately 2.7182818, and it keeps going forever. You might want to locate that number in your calculator because you will need it. There's usually a button that looks like probably e to the x, and that's the one you need. Okay, and the big idea here, I think is kind of cool. And again, there's an Excel for those of you that did the investment project, or if you didn't, if you want to look at it, it sort of explains where this formula comes from. It turns out that the last formula we had, so we had A equals P. You don't have to write this down. I think this is just an interesting thing to note. What happens with this formula is that as n gets really large, the answers when you start plugging stuff in here, no matter how large n gets, eventually the answers start looking like this. And so we say in calculus, you'll learn that as n goes to infinity, we say that P times 1 plus R over N to the NT, this basically starts looking like P times E to the RT. Specifically this piece here starts looking like an exponential function. And if you graphed it, you'd actually see that. Or if you look at that that Excel worksheet that I've done before, you'll actually see that. So let's go ahead and solve some problems. Actually, they're the same 4 problems that we just did in the last few videos. And so if you know how to use formulas, you might be able to just go ahead and do it right now. But I'm going to go over them again. But if you think you can handle the homework, go ahead and start on it. All right, so here it is. Same example. We want to find T, given that A is 17,250, the P is 15,000, and the R is 3.5. And no compounded weekly. Sorry, I forgot to erase that. We're not compounded actually, that's not what I mean. Not compounded weekly, compounded continuously. So this weekly here, you should replace with continuously. That's the new word that you'll see on your homework. And so again, pause, write down the formula, see if you memorize it. The formula is A equals P times E to the RT. In this case, we know A is 17,250. We know P is 15,000. We know the R is 0.035. And what they want to know is T. You don't want to have to worry about N. And it turns out that most of the steps for solving this are the same. It's just going to be a little shorter. I want to isolate the E. I want to isolate the piece that has the T in it. So what I'm going to do is divide both sides by 15,000, which is the same step we did last time. On the left, 17,250 divided by 15,000, if you remember, is 1.15. Here, these cancel, and I'm left with E to the 0.035t. Again, our goal is to get to this t here, so we're going to go ahead and use the function that's called the natural log. This time we have a different reason for using the natural log function, but we're going to go ahead and plug in the 1.15 and this whole expression with e. And in a couple of videos ago, again, everything in math is related. A while back, I had told you guys that if you took the log with the base a and you had a to the x, this is also equal to x. And then we talked about how when you use the natural log of e to the x is equal to x. Well, that's kind of what's going on here. I have a natural log, I have an e, and then I have this in the power. And so what this means is that on the left-hand side, nothing changes, but on the right-hand side, notice that here, this means that whenever you have ln and e together, we just get the x back. So here, that's what I have, so I just get 0.035t. And from here, you guys know how to solve. Just divide both sides by 0.035. And you'll see that t is approximately 3.99, which is exactly what we got last time. So not too much different, except the math might be a little bit nicer. So compounded continuously is almost like compounding at any other rate. All right, let's try another example. Do this one. You might want to pause and try this one on your own. Okay, here we go. So this is the formula. Again, I always try to write it down just to make sure I can memorize it for an exam. It's p times e to the rt. Here again, they tell me that a is, they want me to find r. R is the number here in the exponent. They tell me that p is 50,000, that p is 25,000, that the rate is what they want me to find, and the t is 10. And again, there's a mistake on the slide. Instead of quarterly, it should say continuously. So sorry about that. All the slides will have that mistake, by the way. And then, of course, we divide by 25,000. So we'll get 2 equals e to the r10 or 10r. I think looks nicer. And again, same idea. This natural log function works wonders for us. We have this function, the natural log, and as an input, we put the two things that are equal to each other. And then on the left, we just get the natural log of 2. And on the right, we know that when you have an e and the natural log, these sort of cancel each other. Sort of. I can't say cancel, but they're inverses, so I guess you can think of them as cancel. And then now we have something that's easier to solve. All I have to do now is here divide by 10 on both sides. And so the left-hand side I do with my calculator, and the calculator tells me 0.0693, and on the right I get r, and so the rate is approximately 6.93%. Notice that that's actually different than what we got last time. I think last time we got 6.99, and so this is slightly different. Okay, I think we have time for one more. How long would it take for a deposit to double if it's invested at 13% rate and is compounded continuously? Now for these, I'm going to set it up because this is actually going to be the same thing. So I have a $15,000 deposit invested at 13%, and I want to know how long, which means I don't know t, and I want it to double. Well, double of 15 is 30, but we just did something like this right now. So I will go ahead, I'll let you try this out. Well, actually, let's go ahead and do this. So I would divide both sides by 15,000. You can skip this one if you already know how to do it and go to the last one. And here I get that 2 is equal to e to the 0.13t. I take the natural log of both sides. The natural log and the e cancel each other, so I get the natural log of 2 is equal to 0.13t, and then I solve for t. And so divide both sides by 0.13. And I get that t is approximately 5.33. I think that's slightly different too. I think we got 5.36 last time. So it takes about 5.36 years. 5.33 years. All right. And let's go ahead and fit in the last one. I try to keep these videos under 10 minutes. This might be a little long. But it's the same idea. Well, principal should be deposited at 9% daily to ensure the account will be worth $10,000 in 5 years. And so again, in this problem, what they've done is the formula that we use is A equals P times E to the RT. Here they told us A is 10,000. P they haven't told us. R is 0.09. T is 5. Oh, but this is actually easier. It's 10,000 times P. When I plug this into my calculator, I get a really ugly number. And then now all I have to do is divide both sides by that really ugly number. And once I do that, I get that the principal is about, so P is approximately $6,376.28. So just slightly less than what we got last time. Okay, I hope this helps with your homework, and good luck.